Okay, so let's look at the last problems for today. We're still drawing a 5-card hand from a standard deck. And really, I want to work on the big idea with like, how do you do a harder problem? Like, really, this is the problem I want to answer. How do you get 4 of a kind? Well, I can't really see how to separate the cards. And so what I do is I de-abstract it and I do one example. Let's just say we get one type of 4 of a kind. And I'm just going to do the example. What if I get 4 kings? Okay, so what I did was I make it easier for myself. So let's see, how do you get 4 kings? Well, that one I can do because I would put all the kings in one pile. So there's 4 of them, one for each suit. And I will put everything else in another pile. So that would be everything that's not a king. And there are 12 for each suit. So that's 48. And this plus this is 52. And I would pick. I would go to the kings pile and I would grab out 4. Then I would go to the non-kings pile and I would grab out. I would go to the non-kings pile and I need one more card. And then to get the probability, I'd have to divide by what if I pulled out 5 cards without any restrictions. So this is getting 4 kings. So the question is, how do I adjust that to get 4 of any kind? Well, what could happen? I could get aces, I could get kings, I could get queens, all the way down to getting 2s. And there are 13 different types of cards I could get. So I just have to take 13 and times it by this number that I just found. And it's really a small probability. On my calculator, I got like 2.4, and then it said e to the negative 4. So I hope you guys all remember scientific notation. It's 0.12324. Okay. Okay, there's one other sort of type of card hand that shows up a lot, and it's called a full house. And a full house means you have 3 of one type of card, and you have a pair or 2 of another type of cards. And again, you're like, I don't know how you count that. So pick yourself a particular example. So we're going to do example, what if I get 3 kings and 2 queens? Okay, so how would you get that? There'd be your king pile, there'd be your queen pile, there'd be everything else. So what's that? 52, 48, 44. And so what would you do? You'd go to your king pile and choose out 3. And then you go to your queen pile and you choose out 2. And you'd have to divide that by 52, choose 5. So that's this probability. Now let's see, how do we adjust it? Well, full house, like having 3 kings and 2 queens, that's not the same as having 3 queens and 2 kings. So we got to figure out our counter. Well, we could do it a couple ways. We could think, who do we want to get 3s of? And there's 13 types of cards. And then who do we want to get 2 of? Well, we can't use the one we picked for 3. So that's times 12. But that's the same as where we started our probability unit when we were separated. That's 13, pick 2. So that's our multiplier. So if you do 13, pick 2, that's all the different types of full houses you have. And then times it by this probability, that's of getting a particular full house. When I times it, I got 0.00144.